In this lesson, we shall look at this particular question on momentum. A wooden trolley of mass 2.7 kilograms moves to the left with a constant velocity of 3 meters per second. A bullet of mass 0.03 kilograms is fired horizontally from the left towards the trolley. See diagram 1. Okay, so we have two diagrams here. There's diagram 1, in which the bullet is seen to actually approach the trolley, and this is the instant before collision. We can see after collision, the bullet has penetrated the trolley. The bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. Okay, so it strikes the trolley and comes to rest inside the trolley. After the collision, we can see the direction of motion of the trolley, and this trolley appears to be moving towards the right. Yet, before, it was moving towards the left. And you can see the bullet and the trolley approaching each other before collision. Right, so the bullet strikes the trolley and comes to rest inside the trolley in 0.02 seconds. The average net force exerted by the trolley on the bullet during this time is 591 newtons. The bullet trolley combination now moves to the right. See diagram 2. The bullet trolley combination, here it is, and it is seen moving towards the right. Okay, this is very interesting. It's seen moving towards the right. And the examiner is saying, see diagram 2. And we can see the diagram 2 here. And this is clearly our diagram 1. Ignore all frictional and rotational effects. Write down the magnitude and direction of the average net force that the bullet exerts on the trolley. Right, so we have this particular question. And we need to find and indicate the magnitude. Right. So in other words, the examiner is actually effectively saying you just need to write down the magnitude and what? And direction of the average net force that the bullet exerts on the trolley. Any idea? Who knows? Who knows the answer? The magnitude together with the direction of the average net force. So we need the average net force that the bullet exerts on the trolley, and it's only 1 mark. Who knows the answer? Quickly. Who knows the answer? Quickly. Right. Is everybody lost? All right, the answer is already in the story, because the average net force exerted by the trolley on the bullet during the time is 591 newtons. And now to write down the magnitude and direction of the average net force that the bullet exerts on the trolley, and this is actually clearly 400. Right, so it is, let me just remove these unnecessary ticks here. Right, so it is clearly the average net force. Average net force that is actually of interest is 591 newtons. Okay, so we have that average net force of 591 newtons, but this is not enough. In which direction is it? Because we know that the average net force exerted by the trolley on the bullet during this time is this, but the one exerted by the bullet on the trolley is in the opposite direction. And this is called Newton's third law. And obviously, the one exerted by the bullet on the trolley is 591 newtons to the right. Right, to the right. Right, so this is it. And this is what we want. And this is what we've got. Right, so it is exactly to the right. To the right. Okay, so and obviously if you want to say, you can say it is to the right, or you can say it is 591 newtons, right, in the original direction, in the original direction of the bullet, in the original direction of the bullet. Okay, so this is it. So we have either the first answer or the second answer to answer this question. What question are we answering here? We are answering the question that says we need to write down, so no calculation here, write down the magnitude and direction of the average net force that the bullet exerts on the trolley. Now, I need to explain this because this is due to a principle we call Newton. Right, it's Newton's third law. And the Newton's third law is clear about action-reaction pairs of forces. That if you are sitting on a chair, then the force you exert on the chair is equal and is equal in magnitude but opposite in direction if you are resting on the chair. Right, so this is Newton's third law of motion, and obviously we know that the forces acting on if this bullet strikes the trolley, we understand that the forces will be such that at the instant that this impact happens, you would have forces that are equal in magnitude but opposite direction, and hence write down the magnitude and direction of the average net force that the bullet exerts on the trolley. Next question. Ignore all frictional and rotational effects. Calculate the magnitude of the velocity with which the bullet strikes the trolley. Right, so let us look at this particular one. We need to calculate two things: magnitude of the velocity with which the bullet strikes the trolley. Okay, now this is way too easy. What is the formula that we need to use? What formula are we supposed to use here? Anyone? What formula are we supposed to use? Anyone? Anybody home? Anyone home? There's nobody home here. All right, so now the couple of things that remain very, very important here for us to consider. We know that to calculate the magnitude of the velocity, we know that F net, delta T equals the change in momentum. And this formula here defines the F net times delta T, and F net times delta T is called impulse. This is called the impulse. Okay, impulse. Right, so that now the F net is 591 newtons. Now, the change in time, we know that they were actually in contact for 0.02 seconds. Okay, because it is stated here that the bullet strikes the trolley and comes to rest inside the trolley. It comes to rest in this amount of time. So in other words, the couple of things that are very important, the change in time is 0.02 seconds. Simultaneously, the F net is equal to 591 newtons. Okay, so these are pieces of information that you need to write down so that in the end, then you have the mass into the final velocity minus the initial velocity. And then this is 591. The newtons we can leave out for convenience, can leave out the units in the meantime. And then we're able to realize, therefore, that the mass is what? Right, remember, want to calculate the magnitude of the velocity which a bullet strikes, and what is the actual mass of the bullet? Right, so we know very well that a wooden trolley of mass 2.7 kilograms, right, moves to the right with a constant velocity of these. So it will be very important to understand that we have that the mass of the wooden trolley is 2.7 kilograms, and it moves with a constant velocity of this. So in other words, we will consider that, because for us to calculate the magnitude of the velocity with which the bullet strikes a trolley, we're interested now in knowing what is happening actually with the trolley. And in particular, we're interested in knowing the final velocity. Okay, right. And if the mass of the trolley is exactly this, the bullet is of mass of 0.03 there. Okay, kilograms. Okay, so that in the end, then this trolley is 2.7. And now we have the final velocity minus the initial velocity. Now we make a choice, and we choose a direction. And then right now, if we choose the direction of the trolley, so we choose this direction to be positive. So we choose to the right as positive. And if we choose to the right as positive, then it means that the initial velocity of the trolley would then be negative, because the trolley is in that direction. It's in the opposite direction, and we're choosing to the right as positive. Just take note of that. So that now in the end, then we use our calculators to calculate everything. Let us just check this quickly. So you'd have the 591, right? So what you can do is you can do 591 times 0.02. You divide by 2.7, which equals V final plus 3. V final is equal to 591, 0.02 divided by 2.7 minus 3. And what is the answer here? Right, let us just do this quickly. And if you do this quickly, you'll be able to see that the actual final velocity itself is 1.38 meters per second, and that gives us the final velocity of the trolley there. Okay, and so if this is the final velocity of the trolley, a couple of things then remain extremely important. Right, we're interested in calculating the magnitude of the velocity with which the bullet strikes the trolley. Now we're interested in the bullet striking the trolley, and we're going to divide our board here for convenience, like so. We're going to use the formula for momentum, so that we then say the total, the sum, this means the sum of all momenta before collision is the same as the sum of all momenta after collision. Now we have the mass B, VBI, plus the mass, that is the mass of the bullet, the mass of the trolley, the velocity of the trolley initial, which equals the system right now of the two. So you have the mass of the bullet plus the mass of the trolley, because the bullet and the trolley after collision come together. When they come together, then we add the masses of the two things, and therefore it becomes ultimately the final velocity there of the whole system, of the bullet trolley system. What is the mass of the bullet? The mass of the bullet is 0.03 kilograms. Just leave out the units for now. Right. What is the velocity initial of the bullet? Okay, that is what we want. So that is what you're going to write down here. So the velocity initial of the bullet is actually VBI. plus, then you have the mass of the trolley. Right, the mass of the trolley, we know it's 2.7 kilograms multiplied by the initial velocity of the trolley. What is it? The initial velocity of the trolley. We know very well it was -3. Why is it negative? We chose to the right as positive, and therefore anything that is to the left is therefore negative. Okay, that is why the 3 is negative, because initially we know the trolley was moving towards the left. Now we equate this. What is the mass of the bullet? 0.03. What is the mass of the trolley? It is 2.7. Mass of the trolley. So we add the bullet, the mass of the bullet, which is 0.03, and that of the trolley, we add the 2. And we understand one thing, that the actual velocity of the whole system, it's this one. It's 1.38 meters per second. That is the actual velocity there of the system. Right, so that we have exactly 1.38 meters per second. So that now we have 0.03 pi, which is 11.86. Okay, we multiply everything here, it is 11.86. We perform division to find the velocity of the bullet initial, which is 11.86 divided by 0.03, and therefore the answer is 395.58 meters per second. Because the examiner said the magnitude of the velocity with which the bullet strikes a trolley, we are sure, therefore, that we have got the answer, and the answer has been written as given there. Right, so this is how so we used the formula for impulse. Right, this formula here is impulse. What is impulse? Impulse is the product of the net force and the change in time. And now we understand, therefore, that impulse itself becomes or is equal to the change in momentum. Now, P itself is momentum. What is momentum? Momentum is the product of the mass and the velocity of an object. So this one is called the impulse. Right, the impulse, obviously, of a system associated with the net force and the change in time. And we understand that momentum, by definition, what is momentum? Some of you have not seen momentum yet. Right, so momentum is the product of the mass and the velocity of an object. So if you take the mass and the velocity of an object, you multiply them together, you get what we call momentum P. But we're interested now in studying systems where there is collision. There's a bullet moving, there's a trolley that collides with the bullet. And in the process, we understand that the direction of motion changes. For example, the direction of motion, the bullet was initially moving towards the right and the trolley towards the left. Now the trolley changed direction after the collision with the bullet. Is moving in the direction of in the original direction of the bullet. So these are the kinds of things that pertain momentum. And now when we study momentum, we're interested also in studying delta P. What is delta P? Delta P entails what we call the change in momentum. Now, the change in momentum is seen as being equal to exactly the F net delta T. F net delta T. Right, so any question? Right, so that is the point that we have here. So take note of these things and make sure that you understand these things very, very well. Next point. Next point.
Say.
Yes, please. Any question?
Yes, I have a question, sir.
What is your question?
If say I times, do you see go 2.7, say? If I times with 3 inside there, I will be wrong.
Correct, it's correct.
But I get a different answer.
You get a different answer.
Yes.
Okay, let us just check that together. Okay, because when you multiply, let's just do this. When you multiply here, it's going to be 2,7 B final, and then it's going to be negative times negative, which is plus. Right, 2,7 times 3. You'll have this. This is what you're going to have. There's going to be 2,7 times VF plus the 2,7 times 3. Okay? And then
Oh, yes, I get.
check again. We can show more steps because
Yeah.
What answer are you getting? Okay, because obviously
Yeah.
you need to go through some steps, you know? Okay, we can show the steps and say, for example, we can do this. Doesn't really matter, okay? Because this is just one method I suggested, but it's not the only way to do this problem. You know, we can change this and say, for example, do you have your calculator?
Yes, sir.
Yeah, what is 591 times 0,02? 591 times 0,02. What answer are you getting? This 591 times 0,02. This. What answer are you getting to this?
I get 11,82.
11,82. I need to
Yes.
trust you. And then now we multiply on the right here. It's going to be 2,7 V final plus 2,7 times 3, like this. Okay, so we use the distributive law, the 2,7 multiplied V final, and then 2,7 multiplied 3. Right.
I get 10.
Okay, what are you getting here? Where are you getting the 10?
It's from.
Okay, what is, okay, let's do
For
this.
the.
Okay, you have 11,82 minus, now 2,7 times 3 equals 2,7 V final. What is this? Now, 11,82 minus 2,7 times 3. What answer are you getting? What answer are you getting? 11,82 minus 2,7 times 3. What answer are you getting?
I get 3,72.
You get 3,72. Okay, I need to trust you there. And then now we divide both left and right by 2,7. We divide both left and right by 2, what? By 2,7. And if we do, this 2,7 cancels out, and with V final equals, what is 3,72 divided by 2,7? What answer are you getting?
1,38.
1,38. Okay. Now this is good news because it's exactly what we got here as the actual final velocity of the trolley. Final velocity of the trolley. We need to understand that these two things come together, and therefore in the end we got 1,38, and I'm glad that we are getting the same final velocity. V final is 1,38 there. Okay, we shall do a lot of practice problems on momentum and what you call impulse calculations, where bullets hit trolleys, and with interesting news. Now let us continue and solve more questions. Let's look at the next question by the examiner. Ignore all frictional and rotational effects. State the principle of conservation of linear momentum in words. The examiner is saying, please ignore all frictional and rotational effects. Why? Because now there's normally friction between the surface and the wheels. But also, the wheels are turning, are rotating, so there are rotational effects. The examiner is saying, please ignore friction. And friction is not only between the wheels and the ground or the surface on which the trolley is moving, but what kind of friction do you know that is besides the wheels and the surface? Anyone? Tando. Okay, state the principle of conservation of linear momentum. Here is the principle. What principle is this? It is the principle of conservation of linear momentum. We state it in words, and this is the statement. So now we write it in words. Please come. Yes. How do you know it? What does it state, Nombuso? What does it say?
It says in a isosceles system, the total linear momentum is conserved.
Yeah, definitely. That is the correct one. That's right. And obviously for purposes of examinations and what you're gonna write in November, and this is how you need to state it in November. We say that the total, you need to memorize this, the total linear momentum, the total linear momentum in an isolated, okay, it is the same as what you stated, right? The total linear momentum in an isolated system is conserved. Is conserved. Or if you want to say it's conserved, you can say it remains constant. So the total linear momentum in an isolated system is conserved. If you don't want to say it's conserved, you say it is constant. So these are the kinds of things that you need to take note of. And this is the law or the principle of conservation of linear momentum in words. Okay, right. Right. So we continue. We continue. All right. Okay, so we continue and we solve the next question, 4.4. We need to ignore all frictional and rotational effects. Calculate the magnitude of the velocity of the bullet trolley combination after the collision. Right, so we're going to choose the direction. To the right is positive. And then now you're going to have the summation. The summation of the all momenta. Okay, there is what we call momentum. Momentum to mean that the momentum of one object being mass times the velocity. But if there are many, we say they are momenta. Now, we say that. So, the sum, therefore, before equals the one afterwards, which is the sum of all momenta before collision equals the sum of all momenta final. Initial momenta, all initial momenta added together will equal the final momentum. So this is the summation. Sigma, this is called the sigma symbol. Right, and this sigma symbol, you see it when you do arithmetic sequences and series. Right, so now at this point, to solve this particular question, there are a couple of things that you need to consider here. And you need to make sure that we are on point. So we're going to say the mass of the bullet, the velocity of the bullet initial, plus the mass of the trolley, the velocity of the trolley initial, right, which equals, in the end, the mass of the bullet, because the bullet was embedded in the trolley and the two went together in the same direction. So you have the bullet and the trolley now, they are stuck together, so the mass is the same. And you have the final velocity there. And then now, what is the mass of the bullet? The mass of the bullet is actually 0.03 kilograms. And what is the velocity of the bullet? We got the velocity of the bullet. Right. What was the velocity of the bullet there? And now we got the velocity of the bullet initially, and it was 395.58. That was the initial velocity of the bullet. And we take it forward. And we understand that the bullet was moving towards the right. So its velocity is going to be taken as positive. To the right is positive. So it's positive and it's 395.58 plus. And then we have the mass of the trolley, 2.7 kilograms. But this trolley was moving to the left, so its velocity initial will be negative. The mass of the bullet, 0.03 kilograms. Please, this must be, it must be added to the mass of the, so you add the mass of the bullet and the trolley. The bullet and the trolley, the masses are added together, and we have the final velocity of the overall system. And then if you simplify everything here, we need calculators. Where's the calculator? Nombuso, you have a calculator?
Yes, sir.
Right, 0.03 times 395.58. What is the answer?
3,7674.
3,774, like this.
Yes.
Okay, what is 2.7 times minus 3? 2.7 times 3. Just 2.7 times 3 is enough.
It's 8,1.
It is 8.1. Okay, trust you there, Nombuso. Now we have 0.03 plus 2.7. What's the result?
2,73.
You have 2.73. This is excellent news. What is 3.7674 minus 8.1? Okay, we're trying to see what we're getting here. All right.
I get negative 4,33.
Negative 4.33, then what? 2.6.
2. Yes.
Is it 2.6?
Yes.
All right, thank you. 2.73, the final. Then we're getting the final velocity. What is it? 4.3326. 2.73. What's the answer here? What's the no?
It's negative 0,59.
It's negative 0.59. Okay, something is not right. Need to check the numbers here. There's a number that is not correct here. Okay, I need to. Okay, so I'm going to check this myself. So I'm going to check this just a minute because I need to make sure we get correct answers here. So let us see quickly. Right, so in other words, this is what we have. Right, so let's have this. Right, I'm going to use my calculator to check the answers, okay? So because I want to make sure that we get correct answers. Something is just amiss with these numbers and we must get correct answers. So we're going to start here and say 0.03, 0.03 times 395.58. Let's check the answer. It is 11,8674. What happened here? What happened here, Nambuso?
I made a mistake, sir.
Okay, that's fine. So yeah, because anyway, maybe you added some other numbers here. Maybe you added with this, I don't know, because now it is that. Okay, maybe you added, but it is possible you added with the other numbers, but I'm doing only this. Okay, and if I'm doing only the 0.03 times the 395 point that, and what we're getting is that. So in other words, then we're going to proceed and we're going to make a couple of changes here. Right, we're going to make a couple of changes and we're going to do the following. Right, let us just do this. Right, so I'm going to erase here. I'm going to clean up so that we can make sure that we correct everything when we're still on screen so that you can know what answers, because I'm going to send homeworks. I'm going to send a homework at the end of this lesson. So please get yourself very, very ready because it's just going to be very hectic. Right, it's going to be very, very hectic, and therefore we need to make sure that everybody gets 100% in physics. 100% in physics, but to get 100% in physics, okay, so we are seeing that if you multiply the 0.03 times 395.58, we're getting 11.8674. 11.8674. Can use a decimal comma minus. Okay, let us do the other one right now. So now we're going to do the other one. So we're going to press on here. Then we're going to do 2.7 times 3, which is minus 8,1. Right, so this one here is actually exactly 8,1, which equals, now this one was correct from you. It is 2,73 V final. Now we want to just do now this here. So to do this calculation, so what we're going to do is we're going to actually have 11.8674, 11.8674 minus 8.1. Okay, that is what you wrote earlier. I think there was a mix-up here. There was a total mix-up. Okay, so it is exactly what you got. The 3.7674. 3.7674. That's what I suspected you added with this, you know. And then now that is the reason there that we got a different answer. And then now, which means the final velocity is therefore 3.7674. You divide by 2.73. And what is then the answer? What is then the answer? Okay, now this one. You just check. So it is we're going to take 3.7674, 3.7674. We divide by 2.73, and we get the answer. And the answer is exactly that one there. Right, so it is exactly 1.38. It's exactly 1.38 meters per second. Okay, now this is the answer we're getting. And this answer is so awesome. It's an awesome answer. So which means, therefore, it is exactly this. But remember, it is the magnitude. So no direction must be stated. It is the magnitude of the velocity of the bullet trolley combination after the collision. The final velocity is 1,38 meters per second. Please, it's only magnitude, the size only. No direction must be stated. And so we are done there. Let us move on to the next question. The next question is very, very interesting. It is about learners that are doing a science experiment in the science laboratory. Let us do this science experiment together. Learners conduct an experiment to determine how the initial kinetic energy given to a trolley affects the distance the trolley moves on a rough horizontal surface. What do they want to do, these learners? Listen carefully. These learners, what these learners are doing, they're conducting an experiment to determine how the initial kinetic energy given to a trolley affects the distance the trolley moves on a rough horizontal surface. Okay. So now it happens that you give a trolley some kinetic energy. What is kinetic energy? What form of energy is kinetic energy? It's energy in motion. It's energy possessed by a moving object. So now you push the trolley a little bit. You push the trolley a little bit. And we're arguing that these learners are actually attempting to do and perform an experiment to determine how the initial kinetic energy given to a trolley affects the distance the trolley moves on a rough horizontal surface. Now they're saying, if you give it more kinetic energy, does it move more distance? If you give it less kinetic energy, does it move less distance? And that is what learners are trying to investigate. A learner pushes a trolley of unknown mass until it reaches point A. Okay, here it is. Here is a trolley. This learner pushes the trolley of unknown mass until it reaches what? Until it reaches point A. Right, so Elena pushes the trolley of unknown mass until it reaches point A with kinetic energy, EKA. EKA, now this guy is moving, is giving it an initial velocity. The horizontal distance delta x traveled by the trolley before it comes to rest is then measured. The horizontal distance delta x traveled by the trolley before it comes to rest is then measured. So yeah, then they measure the distance here. If they they pushed it. So this learner pushes. Get the word pushes. So they push this trolley, but now with a kinetic energy key, EKA, the horizontal distance traveled by the trolley before it comes to rest is then measured. So they then measure this distance. After pushing it, they decide to measure this distance. See the diagram below. Okay, here it is. Now they just measure this distance here to say how much distance did it travel after being pushed. But remember, this surface is rough. Because it is a rough horizontal surface, what does it rough mean? It means there's friction. Okay, now let's look at what this. Okay, this is a past exam question. It was set in November last year. So I'm bringing this now because it was set in November last year, but your teachers are doing this in school at the moment. So that is why we're discussing this. The experiment is repeated with the trolley moving on the same rough horizontal surface, but with different initial kinetic energies at point A. So this experiment is repeated with the trolley moving on the same rough horizontal surface, but with different initial kinetic energies at point A. So in other words, right now, they are repeating this, but the kinetic energies are sort of different here. They're sort of different. The results obtained are shown in the diagram below. Okay. Now, ignore the rotational effects of the wheels of the trolley. Ignore the rotational effects of the wheels of the trolley. Draw a labeled free body diagram showing all the forces acting on the trolley during its motion after passing point A. Free body diagram showing all the forces acting on the trolley during its motion after passing point A. After it passed point A, you must show the forces there. So what are we supposed to do there? What are we supposed to do there? Okay, so any idea about the forces that are acting on this? Okay, so in 5.1, this is the answer. So what we're going to do is we need to consider the trolley. We're going to consider it as a particle, but this trolley has a mass. Although, of course, we're told that this trolley is of unknown mass, but we know very well that it has a weight, right? And then also, we know very well that there is something we call the normal force exerted by the surface on the trolley. Moreover, we have the friction force that is in the opposite direction. Friction force that is in the opposite direction. So this is what we have. This is what we have. So if this is exactly the situation, so these are the forces that are acting on the trolley during its motion after passing point A. Where's the question about the free body diagram? So what do you call this one here? It is called the free body. Right, it is called the free body diagram. Who has a different suggestion about this free body diagram? Or where's a question in terms of maybe there's a force that is missing here? But you understand that when this is moving here, it's going to have a friction force that is in the opposite direction. It's going to have a weight that is a force of attraction by the ground, and it's also going to have a normal force. But remember, by the time it passes point A, no one is pushing it. They just gave it energy in motion. They just gave it what? Kinetic energy, EKA. EKA was given to it, and it's just continues moving like that. And obviously, you understand that this trolley has some wheels. No question. In the absence of a question, we move on to the next one, to the next point. Ignore the rotational effects of the wheels of the trolley. The examiner is saying we know that the wheels of the trolley are rotating. So, but ignore all that. Name the independent variable in this experiment. So you must be able to identify your dependent variable and the independent variable. So the independent variable is what these guys are changing. What were they changing here? Anyone? If you're listening, what were they changing here? They were changing the initial kinetic energy because they were pushing it more. So they were changing the initial kinetic energy. Right, because they were pushing it a little bit more and a little bit less, and they wanted to see that if you push it very fast, but very fast, does it cover a greater distance? And then if you push it slowly, and then when it gets to A, you let it go on its own, will it not travel? Will it travel a shorter distance? So, but these guys now, what were these guys doing? A learner pushes a trolley of an unknown mass until it reaches a point A with kinetic energy EKA. The experiment is repeated with the trolley moving on the same rough horizontal surface, but with different initial kinetic energies. So these guys are saying, let's just give it different kinetic energies. We're giving it different quantities of energy in motion. It's moving faster, it's moving slower. If it's slower, will it travel the same distance? If it's faster, will it travel a greater distance? And that is what, so these guys now, the independent variable is actually the initial kinetic energy here. Okay, the initial kinetic energy of the trolley is what these is we can regard as the independent variable in this particular question. Okay, next question. The next question. So we continue right now to do the next question. Right, let's look at the next question. Let's look at the next question. Right, so the next question right now is as follows. Ignore the rotational effects of the wheels of the trolley. The examiner is saying, we know that the wheels of the trolley are busy rotating when the trolley is moving, but ignore all that. State the work energy theorem in words. Who can state the work energy theorem in words? Please state the work energy theorem in words. Anyone? Anybody home? Is everybody sleeping? Is everybody sleeping? Okay, let us state this. So we say that the net. Yes, yes. What do you think? What do you think the work energy theorem states, Nombuso?
I think it states when a net is okay.
Mm-hmm.
It's the net work done on an object is equal to the change in object kinetic energy.
That's correct. So we're saying the net work done. Right. So we're saying the net work done. Right. So we say that exactly. The net work done. Okay. On an object. On an object. The net work done on an object is equal to the change in the objects. In the objects kinetic energy. Right. This is exactly what we state as the work energy theorem in words. Right. And so if this is the case, we take note of the fact that this is it. So in symbols, we say W net is the change in kinetic energy. It is the change in kinetic energy, and that is W net. That is W net. So in other words, the work energy theorem, please listen and listen carefully. So the work energy theorem, this is how you need to state it in the exam because they ask these most of the time. So the net work done on an object is equal to the change in the object's kinetic energy. And therefore, this one is in symbols. Right, this is in symbols, but this statement here is the statement in what? In words. So this is what you need to just take note of. Next question. Ignore the rotational effects of the wheels of the trolley. Calculate the mass of the trolley if the coefficient of kinetic friction between the wheels of the trolley and the rough horizontal surface is 0.18 and the marks are 6. And the marks are 6. And the marks are 6. So what do we do right now here? What do we do right now? So we need to perform a calculation. We need to perform a calculation. So, but this is very, very easy, right? And so to calculate this now, as it is way, way too easy, we need to consider a couple of things here. And so to consider a couple of things, we proceed as follows. Right. We note that the gradient, right, because we need to calculate the mass of the trolley, right? And so to calculate the mass of the trolley, if the coefficient of kinetic friction between the wheels of the trolley and the rough horizontal surface is that. So in other words, we are speaking about the coefficient of kinetic friction, which is 0.18, like so. And so if this is the case, what then is the mass of the trolley in this case? Now, the couple of things, obviously, that we need to consider at this point here. Right. And this means that we have the following. We have that the gradient. Right, the gradient. The gradient is given by change in y, change in x. Right, or alternatively, you can say that this, if this change in y, change, that is gradient, you know. Gradient is change in y, change in x. Or you can say it is change in x divided by the change in the initial kinetic energy divided by the initial kinetic energy. And this is therefore 1 over your kinetic friction, like so. So this is the formula we use here to calculate the gradient. Now, at this point, we're asking ourselves the question, right? If you look at this particular question that we are answering, the couple of things then that remain very, very important. If you look at this graph, you're able to see the distance here. What is the distance? You're able to see that the distance, for example, is 1,5 meters. The change in x is 1,5 meters when the initial kinetic energy is 6, or you can use any other value, but you're going to use exactly that. So which means, therefore, now at this point, we come here and then we say the gradient. So if it is 1,5 divided by 6, which is 1 over the kinetic friction. So we're using this particular formula here. Now, with this then mentioned, we need to solve for F. Right, so to solve for F, you take the reciprocal of this. This is 1 over F, so the answer becomes 6 over 1,5. Right, so now you consider this one. And you bring the calculator here. Right, bring the calculator. You're going to have the 6 divided by 1.5. And it's actually exactly 4 newtons. So, which means that this is actually 4 newtons. Okay, now we continue. So in other words, we're able to see that the force of kinetic friction. Okay, now the formula we use for kinetic friction, we say it is exactly, so I'm going to do this one in green, just for us to be able to see the difference. So which means that the force of kinetic friction is equal to mu k multiplied by the normal force. The force of kinetic friction, we've already got it, it is 4 here, which equals mu, which is the coefficient of kinetic friction, which is 0,18. And now this one here is mg. The normal force becomes mg, which means F is 0,18 multiplied by 0,18 multiplied by the mass multiplied by 9,8 meters per second squared. But yeah, we're just leaving out the units. And therefore, this is 4 divided by 0,18 times 9,8. So yeah, you have that result there. Okay, so in the end, then what you're then getting is the following. Right, using a calculator, let us use our calculator. We already have it. Let us bring our calculator up here. Right, so we have, let us bring this fraction. So we're 0.18 times 9.8. Right. And if you check very carefully, let us cross-check our results. The calculator has displayed an output there, which is 2,27, correct? Which is exactly 2,27 kilograms. 2,27 kilograms. Okay. So now to calculate the mass of the trolley, if the coefficient of kinetic friction between the wheels of the trolley and the rough horizontal surface is 0.18. Right, so that is what we have here. So we've calculated the mass of the trolley here. We found the mass of the trolley. Right. And I think that this is some good time for us to take a break. And I'm gonna see you guys. I always jump one day so that you can have a break and do other things as well. So because today is what day? Today is Tuesday. So tomorrow I'm not gonna see you. I'm gonna see you on Thursday so that you can do other things because you don't only have physics and mathematics, you know.
Sir,
Yes,
before
please.
closing,